Hello everyone. So gladly for me this is my first video. तो देखते हैं कैसा जाएगा. First things first. My name is Adnan Kaksi and I am a civil engineer graduate from NIT Jalandhar. नाम का ही हूँ civil engineer, but फिलहाल इतना काफी है. So I'll come up with short discussion videos on physics, and those videos I'll try to make them crisp and conceptual. So today I will discuss on massless inextensible string. So my question is that whenever we consider this situation, why do we say that tension at all points is zero? All points is same. Like for this string, if there is this string, okay, and we always say that tension here is T, then tension here will be T, here will be T. Everywhere tension will be same. Okay, and you must have seen this in pulley mass system. You will take tension at both the ends of the pulley, both the sides of the pulley. You will take tension in string to be same as T. But why is it so? So intuitively you can answer this, but can you prove it? Actually, you have to prove it, and conceptually this is very important. So for this, let us actually let me take one string. So for this string, let us say it has some mass m, which is for massless string, mass will tend to 0, and it will have some acceleration. So acceleration is there, and which is defined, always defined. Acceleration is there, and let us assume that tension is not same at both ends. And even if you think this way, that if there is some acceleration, then you need to have some net force on the string. Without net force, how can there be some acceleration? So this is one anomalous question that comes in mind. So from Newton's law, if I take F net is equal to mass into acceleration, and what is net force, which is nothing but if T1 greater than T2, it will be T1 minus T2. So acceleration comes out to be T1 minus T2 by m. This looks fine until I tell you that this mass is nearly 0. Then this T1 minus T2 acceleration becomes T1 minus T2 divided by 0, which is goes to infinity. Now this is the issue, that how come it's infinity, coming out to be infinity, when we have actually know that it has some value which is not infinity. This has some defined value. So even in determinants, if you guys have studied in maths, you will learn that for a system of equation to have finite solution and not infinite solution, then either there are two ways, that delta is not equal to 0, you learn ahead, and or delta not equal to 0, and if delta is equal to 0, then all the other determinants will be equal to 0. So this is you learn in your course ahead in maths for the maths students. For biology students, let me explain to you in simple way that if acceleration is coming out to be infinite and we need to make it some finite value, then either it can have some defined finite value, which you will generally solve in so pulley mass system. You will get some finite value of acceleration which is defined, or you can either make this acceleration not defined. So this not defined condition gives us some scope of having a finite acceleration. How so? Let us say 0 into 2 is equal to 0, or 0 into 7 equal to 0, or 0 into 1 1 1 equal to 0. For all this condition, I can say that 2 equal to 0 by 0, or 7 equal to 0 by 0, or 111 equal to 0 by 0. So a 0 by 0 condition is such condition which can assume any value, any finite value, and we call it not defined. Why not defined? Because it can be either 2, either 7, either 11, but at least we are sure that it will be a finite value. So this guarantee, this condition provides us. So to make this acceleration of finite value, which we know that it should be finite, acceleration cannot be infinite, we will have to make numerator equal to 0. So we can say that t1 minus t2 will be 0. So acceleration comes out to be of form 0 by 0, which is not defined but some finite value which is possible. So from here we say that from this concept we say t1 is equal to t2 equal to t, and this is why for massless inextensible string tension is constant value at all points.